what I'm going to show you is the most basic thing that people expect when they're running staple applications in production, which is high availability, right? So when you deploy Portworx, the first thing Portworx does is, well, as you can see here, it itself is deployed as just another application container, which is managed by Kubernetes. So typically when people are running, for example, Portworx in OpenShift, OpenShift is managing the lifecycle of Portworx. What does that mean? There's an operator that's deployed. So OpenShift will upgrade Portworx if there's ever a new version of Portworx. Or if you add a new node to your cluster, you as a platform admin do not have to pre-provision Portworx or install Portworx to it. OpenShift will install Portworx on it. So all of this is kind of taken care of. And the first thing it does is it fingerprints your environment. It goes and looks at different kind of storage technologies that you have in your cluster. It looks for the presence of different types of drives. To the earlier question, it looks for, hey, I found some SSDs here. I found some NVMEs. This happens to be a Samsung NVMe. And so it kind of has all of this knowledge that it's creating about your infrastructure. In fact, your infrastructure could be heterogeneous, right? So what I mean is you could have some servers that have storage drives on them, and maybe some servers are connected to a SAN, and maybe some servers don't have any storage. And so Portworx knows what to do and how to use it, and I'll walk through how that works. And from here, whenever the end user deploys an application, for example, MySQL, it gets a container granular virtual volume from the Portworx layer. The property of this volume is that it's not attached to a machine, it's part of that container. That becomes the biggest difference between what we've done and other approaches. What this lets us do is if there were any, for example, a machine failure or a drive that's failing, not a problem. Kubernetes can instantly move that container to another machine in the cluster and continue to run without any loss of access to its data. So that'll be the first live demo that I show you. The second thing that's important is density, right? We find that when people are running containerized applications, see, typically on a physical server, maybe you're running a few dozen VMs. When you're running containers, you're easily running hundreds of application pods per machine. So density is really important. So this notion that Portworx needs to be lightweight, agile, nimble, and cater to hundreds of containers is an important concept. You guys are familiar with this notion of boot storm, right? What happens when a server goes down and all of a sudden a dozen VMs need to come up and boot up, and that's called a boot storm. Well, that problem has been magnified at least 10x now, because if a machine were going through an upgrade and Kubernetes needs to drain a worker node, it needs to reposition easily a few hundred containers, and that taxes the system in a different way. And so those are some of the design challenges that we've had to address. But we also find that customers are running not just one Kubernetes cluster, they're running multiple Kubernetes, or managing fleets of Kubernetes clusters. So this ability to migrate data or manage data across clusters, even if it's between on-prem to the public cloud, has been extremely important. This will be the second demo that I show how Portworx can manage your data across different Kubernetes clusters, all the while maintaining end-to-end security. So with that, I'm going to switch to a demo, but let me just pause there and see if there are any questions from the audience. One of the things that you can do, actually two things. If you guys have a Kubernetes cluster already there and want to try it out, I encourage you to do that. You can simply go to install.portworx.com, and it will walk you through how to deploy a couple of different Portworx products. Essentials is a free version. You can see its spec over here. If you want to run enterprise, you would just basically answer a few questions about your environment. I'm selecting here the operator method of installing Portworx, which is the easiest. And then you can select your target environment. And again, it is here that Portworx will load the templates for how it needs to manage the backend storage. I'm just, at this point, asking Portworx to auto-detect the storage available. And so there's a module called Autopilot that's part of PX. Autopilot will go in and figure out what the environment looks like and how best to use the storage in your Kubernetes cluster. If you're running in the public cloud, you can pick any one of these cloud providers, and it will load the template for how to deal with that cloud provider. So you can fill out those questions, and let me just quickly get through this. And then I typically leave the networking section default. And then you can select your target environment. If you're running vanilla Kubernetes or OpenShift, select your environment. And that's it. At this point, you get this install spec string. If you take this and run this in your Kubernetes control plane nodes, it will take a couple of minutes to download the Portworx components, and Portworx should be up and running. If you want to try it out without having a Kubernetes cluster, you can also go to docs.portworx.com, which I encourage you to do. Go to interactive tutorials and click on this education section. And there's a number of different tutorials here you can try, which is a live environment. I'm going to do that. One of my favorite ones is this Postgres environment. So this will be my first demo. So let's go through this live.
So maybe a question for me before we move on. So you're showing, a kind of easy workflow to get started in greenfield environments. That's always the easy part. Unfortunately, storage, it's hard to manage, hard to move. It's inert, right? It wants to stay where it is. So how do you handle existing storage containers, either in the public cloud or in an on-prem, maybe a SAN or a local server somewhere?
Yeah, so there's two ways I can interpret that question. I just want to make sure I got it correctly. If somebody already has an existing SAN, Portworx can carve out a volume from that SAN and use it. It can do that programmatically in certain environments where it knows how to talk to the SAN. Typically this is, if you have something like VMware, it becomes very easy to do that. Normally, the most common method that people do is that they just attach a LUN, right, from their existing SAN to the worker nodes that they want Portworx to run on, and Portworx will just pick that up and work with it. So it doesn't have to be a brand new environment that's set up for Portworx. Just to take that one step further, somebody may already have some containers that are running that have already consumed some storage. Portworx has an import functionality to be able to import data from that into the Portworx PB as well.
And does the data then need to be copied or moved or whatever, or will it reuse whatever storage container is used on the background?
It would have to be moved over because we now have to provide the functionality at our layer. So that data has to get inserted under our SDS layer. So it has to be moved over.
Okay.
Hey, Goo, real quick.
Yeah.
You mentioned a few slides back. You were talking about OpenShift. So when we put Portworx down in our Kubernetes cluster and all that, if it's an OpenShift that handles all of the moving parts, I guess I could sum it up with that. It manages all the moving parts for Portworx. Does it also do the same thing in a vanilla deployed Kubernetes environment? So if I provision my own environment and install Portworx and I add and remove, obviously removing nodes may not be as important, but adding new nodes, it handles all of the additional things? Or is it just literally just relying on the constructs of Kubernetes itself to make sure those policy claims and those volumes and everything are defined already? But is there a daemon set or something that needs to run on every host? I guess would be a good word.
Yeah. No, it's a great question, Larry. So Portworx does deploy as a daemon set under the hood. So we conform to the most common part of the Kubernetes environment, which is just the Kubernetes control plane. So while a number of our on-prem customers choose to run OpenShift, we ourselves have no direct dependency or reliance on just OpenShift. So we support truly any Kubernetes control plane. Like I mentioned in the public cloud, a lot of our customers use the cloud providers Kubernetes control plane, whether it's EKS or GKE.
Right.
Yeah. And actually, in this case, I'm actually not running OpenShift. This is just vanilla Kubernetes. So I've already done the install here. This is a live environment, and you'll see here that there's a single master and 3 worker nodes. And on the left-hand side, for those of you familiar with Katacoda, it's a fantastic environment to bring up a quick cluster, which is what I did here. And I'm going to follow the script, but you don't have to. You can just go to this, go to it through docs.portworx.com and poke around with it. You'll see here that Kubernetes is managing Portworx. To your point, Larry, it has been deployed as a daemon set. So that is what I'm listing over here. And there's actually 3 Portworx containers that are part of this daemon set. And what I'm going to do here is because you guys are highly technical, I'm going to break out of this script. I'm not going to follow this script. I'm just going to show you what's going on under the hood. So I'm going to SSH to one of these worker nodes. And normally you're not doing this in a production environment. A lot of times you don't even have access to the worker nodes. But I want to do this so I can show you, poke around the system. If I query the Portworx status, and by the way, everything that is running within Portworx is running inside of the container. Even though I'm using the PXE CLI, that CLI is actually running inside of the Portworx container. So there's really nothing at the host. So if I list the status, you'll see here that there are 3 nodes. Each node has a 20 gig local drive. If you do an ls block, right, you'll see that VDB, that's our disk. This is a playground environment. There's not a serious environment, so it's just a 20 gig drive. You'll see here that we've detected that the backend storage is a magnetic disk. It's showing in green because it's currently healthy. There's nothing wrong with the drive, and I'll make some errors in this environment. Also, if I list the volumes, there are no volumes currently because it's a brand new environment. So there's nothing going on in the system. So let's flip back. And now what you would do as a platform administrator is you would create these storage classes. So this is, there was a question asked earlier, which is, how are the PVs mapped? So I created these storage classes. So anytime a PVC is created now, it will automatically reference this claim. What I'm doing here is in this demo, it's a Postgres demo, so I want to run a database. I'm requesting high IO priority, which means that wherever Portworx detected the drives that are capable of driving higher IO priority, that's where we will automatically stage the data. End users are not talking to Portworx. I'm just using kubectl to create a PVC. If I go to the back, a 1 gigabyte virtual volume has been dynamically provisioned. It is currently detached because there's nobody using it. And you can see the various properties associated with this. So let's go ahead and what I'm going to do here is I want to run Postgres. So that's my Postgres spec. And I'm simply going to tell Kubernetes to start Postgres. And in a matter of a few seconds, I already have a database up and running. When I'm talking to a customer, right, I'm explaining the power of this entire platform and the cloud native way of thinking. Contrast this, right, in a machine-centric way of doing things. If you had to get a database up and running, how long would it take? Here, without talking to a storage admin, just using Kubernetes as an application developer, I created a volume. Without having to talk to my VI admin, I can create a compute resource. I'm running a database, and literally it took me a few seconds to get a database up and running. If you go to the back and to the worker node, again, you're really not, nobody's doing this in a real environment. But if you look at the volumes, you'll see here that Portworx has attached that volume on .98 because that's where that database is running. So let's do this. I am going to actually skip this. I'll come back to that. I'm going to now connect inside of the database. So at this point, I have exec into the database. I want to show you one thing. Inside of this database, if I do an ls block, you see something interesting. This is the Portworx virtual volume that is attached inside of the database. This is an important concept. This volume is not part of the machine. It's only visible inside of that container, and it's available wherever that container runs. The Portworx SDS layer is taking care of that, and we even know that it is part of a Postgres container, and I'll explain that in just a moment. Okay, so what I do here is I'm going to create a database called px-demo, and I'm going to write about 5 million records to this. The reason I'm doing this is while this database is running, I'm actually going to shut this machine down. So this worker node, I'm going to simulate it as if it's not available. I'm running this. Think of this. I'm work for a bank. I've provisioned a Kubernetes platform. There's a database that's running. 2 in the morning, machine shuts down. What happens? How does this environment react to it? That's what I want to show you here. If I were to inspect this volume, there's a couple of important things that I want to point out. You'll see here that Portworx has, because of how it's integrated with the Kubernetes control plane, we know that it's a Postgres container that's running. It's listed over here. We know which namespace it's running in. We know which controller it's controlled by. The various nodes that are the preferred set of nodes where we know we can deliver that high IO priority. Also, from a chargeback mechanism, we're keeping track at a container level how much space is being consumed by that container, which namespace. So if we had to do chargeback or if you had to set quotas, we can enforce all of that at a Kubernetes level, right? Using the Kubernetes grammar, all of these things can be enforced. If this were encrypted, which it's not, we'd show you which namespace that it were part of. So all of this information is being provided. Normally, our customers would enable things like Prometheus. They have rich Grafana dashboards where they can visualize how their Kubernetes platform is running and which department is consuming how much space. All of this information is being provided at Kubernetes granularity with application specific details. So this is my database. Let's just go back and which machine is it running on? It is running on .98. Keep an eye on that. What I'm going to do is connect to .98 and terminate that instance. So I'm simulating that machine going down. Maybe the machine crashed, there's a network outage, power failure. What happens, right? What's going to happen here is in a matter of a few seconds, Kubernetes is going to detect that that machine lost a heartbeat. You'll see here that that application is already up and running. If I go to the back and I list the volumes again, you'll see here that that volume moved from .98 to .50. I'm going to connect back to the database because I'm an end user. I don't care if a machine crashed. It's not my business. I get back into the database, and that's my 5 million records, no loss of access to the data. So this is the most basic requirement to be able to run mission critical or enterprise grade workloads on the Kubernetes platform.
Years ago, one of the challenges, obviously, in containers like Cassandra, things like that, having multi-data center and all that. Do you guys also facilitate? I mean, it's great we're seeing like a node failure, but how does this look from a data center failure where you're going to fail over to another site and you need to make sure things are in sync and all that?
Yeah, great question, Larry. I'm glad you brought it up because I forget if I was going to explicitly cover that or not, but it's an important topic, so let me talk about it here. Here, what I'm showing you is machine failure, right? But obviously, people care about even other kind of disasters that could happen. Or I don't want to make it sound like a disaster because that kind of is putting I'm putting fear in somebody's mind. That's not the case. Normally, some simple thing will happen where people will momentarily lose a rack, right? Okay, so what does this mean for us? And what does application awareness mean for us? And we are keeping track of data center topologies. So when we provision volumes, and I think you mentioned Cassandra as your example. Well, let's go through that. Okay, there are two ways we could provision storage. Somebody deploys a 3-node Cassandra cluster. So there's 3 Cassandra containers. We could take the data and put it all on 3 different machines in the same rack. Well, that would be the worst thing to do because if I lost a rack, I'm losing my entire Cassandra cluster. So what we do is we know when we're provisioning storage that it's part of a 3-node Cassandra cluster. The first node's volumes will go on, so we call them availability zones, right? Mm-hmm. So a rack becomes an availability zone and we'll spread it across availability zones. To take your scenario one step further, when we're running in the public cloud, let's say somebody's running in Amazon and they're running in the US West region, well, they have US West 1, US West 2, so available AZ1, AZ2, and we know where their the EBS volumes are, and we'll spread it across the availability zones. So we're taking care of that implicitly. The end user doesn't have to do anything to make that happen.
Okay. So there's not really like, so when I think about that, I'm thinking like there must be a higher abstraction upstream that's actually managing kind of that cluster. Let's look at it from a cluster perspective.
Yes,
from a data synchronization, is that where that happens?
That's correct. And if you recall in the slide, I'd shown you this. There was this layer that's called the PX control plane layer.
Yep.
It is that layer that is extracting that information. And there are a number of different ways we can get it through node labels or talking to the cloud provider or trying to figure it out. But yeah, that happens explicitly. Actually, if I go here, see in this, if I do a status over here, this is again Katacoda. This is the cheapest environment, right, for us. So we don't. It's not running in a multi-AZ environment.
And this, what you've just shown, is more from a resilience point of view, availability point of view. I was just wondering that are there any mechanisms that basically scale with performance requirements. So you define a particular performance level, and then the cluster sort of expands to deliver that kind of performance. And how do you do that, if there is such a thing?
I hope I understood the question correctly. Let me. So first of all, the mileage for us varies with the infrastructure, right? So the performance we deliver is relative to the environment that we're running on and the type of servers that we have. You mentioned expand. So if somebody were to bring in, let's say somebody started with 3 nodes that had spinning drives, and by the way, this is one of our visions with Pure, right? Because where we see the Kubernetes ecosystem currently is over the past 2 to 3 years is when serious production deployments have started to happen. What happens whenever any new technology starts getting into mainstream production? People typically run into the following issues, right? Capacity, performance. They start realizing that, hey, Kubernetes started out as a small project, but now I'm running more serious workloads on it. I need more performance, and obviously resiliency and so on. So on the performance aspect, let's say somebody had a 3-node cluster. They were running in VMs because it was a small Kubernetes project. Now they onboarded a lot more users, and they decide to deploy the flash technology from Pure. And so they just throw in a Pure array. Portworx can detect that and then decide to leverage that for additional bandwidth capacity, use it for tiering, right? So get the hot data to sit on flash, and then the colder data to sit on the older tier. Portworx will do that too automatically.
That's exactly why I was asking that question, that because this subsystem, basically whatever storage you're running on can change, but also, for example, it's a service level, if you like. So for example, if that cluster was running a particular workload, that just because of sudden influx of users or them reducing, so you don't need as much cluster resource, so that can grow and shrink based on the service level that needs to provide to that particular function. And that's what I was wondering if that's available.
It is. And, especially in the financial sector, these kind of things become more than just a requirement, right? They won't even move their applications to this OpenShift platform if they can't have a way to enforce these things. So it's a great point. Okay.
Just a quick time check. We got about 15 minutes left, Gu. So maybe
move a little bit faster. Okay, I'll just I'm going to do just one other, a couple other quick things. And so I'm going to connect back into this database, and let's go ahead and add some more data to this. The reason I'm doing this is to kind of show you some of the automated functionality that exists within Portworx, that autopilot kind of feature. Here, what's going on is I added too much data, and you'll see here that the Postgres database errored out. If you go to the back and you were to inspect the volume, you'll see here that Portworx has thrown an alert saying that, hey, this volume is at 90% capacity. And normally this is a problem because, most application developers don't know how much capacity they're going to consume. But because you have Portworx and the SDS layer, autopilot can kick in, and I'm doing this by hand, but autopilot can automatically kick in and take care of resizing that volume and making sure that the database continues to run. Which is what I did over here. I manually triggered autopilot, and you go in and inspect the volume. You'll see here that the volume has been virtually resized to 10 gigabytes. For the storage experts here, think about all the things that need to happen and why I call this application-aware storage. We had to go in and not only expand the block volume capacity, but resize the file system and then allow the database to grow into it. So in order to do that, there's a lot of things that need to happen. And you can't do this if you're an externally managed storage system. So it is very important to understand that our technology is running on the Kubernetes worker nodes, which is what allows us to do these kind of things.